Hello and welcome back to my channel. Students, as you all know, we are doing general organic chemistry, and in this topic we have already covered 23 problems, and those problems were based on some of very important topics like carbocations, carbene ion, aromaticity, anti-aromaticity, resonating structures, acidity, basicity. Now, let us try to see what is there for us in question number 24. So if you see, as you can on this screen, you have a compound, and this compound has 4 nitrogens labeled as A, B, C and D, and you have to predict a decreasing order of their basicity. I have already told you the basicity of nitrogen is based on its tendency to give away the lone pair it has. Now, the tendency now depends on availability of electrons, and availability may get affected because of the neighborhood. For an example, if that lone pair is in conjugation, then because of that conjugation you can draw different resonating structures, and you will find that the lone pair gets delocalized, goes away from this nitrogen, and as it happens, the availability of lone pair on nitrogen decreases. So you should remember that higher the extent of conjugation, more you can delocalize that lone pair on more number of atoms, lesser will be the availability of lone pair on that nitrogen, and because of which the basicity of nitrogen will decrease. So having said that, let us try to see each case in a very fundamental way. So I will start with the nitrogen number A. Once you see the nitrogen number A, you find that it is having a lone pair, and nitrogen is a part of a ring which is aromatic in character, because you can see it's a 6-membered ring and it's flat, and there is a cyclic conjugation, double, single, double, single, double. So it's a part of an aromatic system, and you understand, if you try to find the hybridization, of this nitrogen, then it is very interesting that you have to find the sigma bonds and lone pair associated with this nitrogen. So you can see there is one sigma bond here, one sigma bond here, and this is a lone pair. On this account, you can say that the steric number, that is the sum of sigma bond and lone pair, is 3, and therefore the hybridization must be sp2. So sp2 hybridization means the 2 sigma bonds and the lone pair are on the same plane in trigonal planar manner. So having said that, let me give you a picture and will make you more clear. In the previous slide, I told you that the nitrogen I am talking about, this is the nitrogen I am talking about, is part of an aromatic ring, and the 3 pi bond you can see 1, 2, 3 are part of aromatic sextet. And as I have already said, the nitrogen is sp2 hybridized, and sp2 hybridized means the 2 sigma bonds I am talking about and the lone pair I am talking about will remain in the same plane. So once you find that this lone pair is in the same plane as of the ring, then you come to a conclusion, a logical and technical conclusion, that this lone pair is not parallel to the pi system of the ring. Because if, for an example, this is ring and there is a pi system like this, the lone pair is like this. So the lone pair is perpendicular to the pi system of the ring and therefore not parallel. Therefore the lone pair is not in conjugation with the pi system, and because of which the lone pair will not get delocalized, and therefore it will remain on the nitrogen, and therefore the availability of electrons will be higher. So that is an important point to see. Now you should understand, if this is the case, the lone pair on A remains localized, and you should not count it in conjugation like lone pair, single, double. You should understand this lone pair, single, double is just for the sake of showing it is not happening practically. So it's not in conjugation. And why it's not in conjugation, I have explained in the previous slide that this lone pair is not parallel to the pi system and is perpendicular to the pi system. So that you have to take into account. Now, so you have come to a conclusion that this lone pair is going to remain on this nitrogen, so it is localized. And localization of lone pair is good for the basicity of nitrogen because the availability of electrons has increased. Now coming on to the nitrogen number B. Once you come to see nitrogen number B, and as you know from this diagram, this is our nitrogen number B. This is the lone pair which is under scanner, which is you have to see whether it is more available or less available. Once you watch for this lone pair, you see that it is straightforward in conjugation with the aromatic ring. How? Lone pair, single, double. And because of this conjugation, it will get delocalized, and once you do that, you will delocalize these electrons like this. And as it goes away, it makes a pi bond, and these pi electron will shift on this particular carbon, bringing a lone pair and a minus formal charge, as you can see in this figure. Again, you find that this is still in conjugation with a pi bond nearby, lone pair, single, double. So again, this is going to delocalize in the forward direction, and this pi electron are going to sit on this carbon, and you have from this structure came to this structure. Now once you realize that the minus charge and lone pair are staying at this carbon, you believe that it could go this way also because there is a conjugation minus, single, double. Or it may go this way also because again there is a conjugation minus, single, double. So both ways you have to draw the resonating structures. So as it goes as minus, single, double, I have made the structure here as you can see, and as it goes this way, the double bond comes here. These pi electrons are going to sit on the nitrogen to bring one more lone pair and a minus charge. So the nitrogen number D, because of this phenomena, has acquired two lone pair that you have to keep in your mind. And if it goes upside, then again it moves like this, and these pi electrons sits on nitrogen number C, and from there you get this structure. So here also, because of this resonance, the nitrogen number C is acquiring two lone pairs. So you should understand the lone pair of B is not localized, and because of conjugation it is getting delocalized and spread over many atoms. And because of this delocalization, the availability of electrons on nitrogen number B decreases highly, and therefore its basicity also very less because it delocalizes to a large extent. However, because of the delocalization of the lone pair on B, two nitrogens gets benefit also. Which are those two nitrogens? You can see the nitrogen number D has acquired now two lone pair because of this delocalization, and not just D, the nitrogen number C also got the two lone pair because of this delocalization. So the B is getting demerit because of the delocalization. The basicity of B is decreasing, but because of B only, the basicity of D and C are increasing. Why? Because they are acquiring one more lone pair because of that resonance process. So you have to keep all these things in your mind, and while we will discuss the 4 cases in comparison, we have to bring all these points on front. Now let us see the nitrogen number C. As I have already spoken in the previous slide, the nitrogen number C has got one lone pair that will remain localized on nitrogen number C on the same logic as I gave for A, because this is sp2 hybridized and remain in the plane of ring and will not go in conjugation. So one lone pair was already there, and one came, as I showed in the previous slide, because of the conjugation of the lone pair of B with the ring. A second lone pair comes on the C. So altogether the C has got 2 lone pairs now. Now coming on to the nitrogen D, again you saw in the previous slide that because of conjugation of the lone pair of B, this nitrogen D got 2 lone pairs finally, and one lone pair it had originally, and that was sp2 hybridized, and because of that it remained localized with the nitrogen, and one lone pair which it gets more is because of the nitrogen number B. So you again see the D has got 2 lone pairs. So now you have to keep every point in your mind while comparing all the 4 and telling what is the final hierarchy. Now once you see all the features, you find that this is very important diagram I have drawn, that the C also had 2 lone pairs because of the conjugation of the lone pair of B. The D also had 2 lone pairs because of the conjugation. So what is the point which can differentiate between C and D? You understand, the point is, after you gave the lone pair of D, after you gave the lone pair of D to hydrogen, you understand one hydrogen comes and the lone pair is given to this hydrogen and a plus charge comes on nitrogen. Now this hydrogen can make an intramolecular hydrogen bonding with the lone pair of the A, and this intramolecular hydrogen bonding releases energy and is good for the health of this conjugate acid, this cation, because there is an attraction developing in these 5 atoms. A 5-membered ring is created due to intramolecular hydrogen bonding. That will not be happening in the case of C. The intramolecular 5-membered or 6-membered ring cannot be formed in the case C after the lone pair is given to hydrogen. On the other hand, in the case of D, once the lone pair is given to hydrogen, the hydrogen can make a 5-membered ring and can involve in a very good intramolecular hydrogen bonding that releases energy and stabilizes it. So on this account, you can tell that D is more basic than C. Now coming on to A and B, you understand, in A only one lone pair was there. On A just one lone pair was there, and B the lone pair was delocalizing because of resonance. So you should understand, on A one lone pair remained localized, on B the lone pair got delocalized, so less available, but on D and C both you got 2 lone pairs because of the resonance. So most number of electrons you found in the case of D and C. Then will come the A because it had one lone pair, and the least electrons are going to be with the B because the lone pair of B got delocalized into the ring. So on this basis you can now tell that the D is going to be bearing two lone pairs in one of the resonating structure. C also will bear two lone pairs in one of the resonating structures, and because of more availability their basicity is more. However, amongst C and D, D has some edge, some benefit because of the intramolecular hydrogen bonding, which is good for the cation it makes after giving electrons to proton. On the other hand, C does not make such 5-membered or 6-membered intramolecular hydrogen bonding. Now coming on to A and B, A had the one lone pair in all the resonating structures localized, and the B, it lost the electron due to conjugation, so it was the poorest in terms of electron availability. And that is how you have to think in terms of the availability, which depends on delocalization, which may get benefit from the delocalization also, as we saw in the case of C and D, its lone pair not getting delocalized, but from somewhere else because of resonance it is getting one more lone pair. So the resonance from a remote area can help in increasing the basicity of nitrogens, as we saw in the case of C and D. So I hope you all must have got the very important point I intended to make through this problem, and similarly all the problems you all must have got all the concepts I want to convey. And keep watching my videos. And if you have any doubt, I keep on repeating this statement. If you have any doubt, if you have any question, do ask me in the comment section. I will be the happiest person to resolve those doubts. Okay, till then, take a good care of your health and happiness. Thank you very much.